For 4,500 years, the Great Pyramid hit a void the size of a commercial airplane, and we only found it by tracking cosmic rays from outer space. Welcome to this explainer, where we're diving into the ultimate ancient mystery. But today, we aren't dealing in myths, and we're definitely not dealing in alien speculation. We are bringing hard archaeological evidence and cutting-edge particle physics straight to the Giza Plateau.
We're going to explore how modern science is completely rewriting our understanding of these ancient stones. Seriously, if you think you know how the pyramids were built, prepare to have your perspective totally flipped by the data. We're taking a journey from the incredible logistical genius of the Old Kingdom all the way up to secret voids that were discovered as recently as April 2026.
But first things first, we've got to clear the air and tear down the oldest myth out there, the one recorded by the Greek historian Herodotus. The archaeological reality is stark. The pyramids were absolutely not constructed by slave labor. Instead, they were built by a highly organized, really well-compensated, and incredibly skilled workforce of over 20,000 people. This wasn't some brutal slave monument. It was a massive national unity project that brought specialized workers together from across the entire country.
To really understand how they pulled off this monumental feat, we just need to look at the ancient records.
2.3 million. Think about that for a second. Moving the 2.3 million stones required for the Great Pyramid was an absolute logistical nightmare. It demanded unparalleled state organization. We're talking about an average block weight of 2.5 tons, with some of the massive granite beams weighing up to 50 tons, and they moved all of this without modern machinery. So how on earth did they feed, organize, and pay the tens of thousands of people doing this work?
Well, the answer actually lies in the Diary of Menkaure. Discovered at an ancient Red Sea harbor, this 4,500-year-old papyrus literally functions as an ancient spreadsheet. Inspector Menkaure managed teams, or files, of up to 200 men, and his ledger tracks their daily compensation down to the finest detail. And get this, they weren't given meager scraps. They received high-quality rations of beef, sheep, fresh bread, and beer. It proves without a doubt that this was a deeply organized and socially rewarded workforce.
Inspector Menkaure logbook outlines a stunningly precise, multi-day supply chain. His crew would spend a day extracting bright white limestone at the Tora quarries. Then they'd spend 2 days transporting these massively laden boats down the now extinct Aramat branch of the Nile River, which is actually a waterway that researchers only just mapped to be a satellite back in 2024. Finally, they'd make a quick, one-day unladen return trip. They did this constantly, like clockwork.
But getting those stones across the Nile to the Giza Plateau, that was really only half the battle. They actually had to dredge a deep basin called Lake Khufu just to bring these massive barges right up to the construction site. Yet, even with the stones at the base, we still hit a massive engineering paradox. How did they lift millions of tons of rock hundreds of feet into the sky? And that brings us to the highly debated internal ramp theory.
For decades, textbooks told us they use a massive, straight exterior ramp. But honestly, mathematically and spatially, a mile-long ramp is simply impossible on the steep topography of the Giza Plateau. It would have required more material to build the ramp than the pyramid itself. And what about an exterior spiral ramp? Well, that would have completely blocked the vital sightlines the architects desperately needed to ensure the pyramid's corners met perfectly at the very top.
But the physical evidence for a totally different approach might be hiding right in plain sight. French architect Jean-Pierre Houdin proposed a radical idea, an internal spiral ramp. He argues the pyramid was actually built from the inside out. A visible notch on the exterior, along with a hidden L-shaped room near the pyramid's edge, perfectly aligns with exactly where an internal corkscrew ramp would need to turn.
And the crazy part? The data actually backs him up. A 1986 microgravimetry survey, which essentially measures the density of the pyramid, surprisingly detected bands of lower density along the outer edges. For years, this data was just ignored, but when you compare it side by side today, those low-density bands perfectly match the predicted path of Houdin's internal corkscrew ramp. The ancient builders likely just left the ramp inside and covered it up.
Which leads us perfectly into the era of muons and the big void.
Enter muon tomography. Back in 2015, the Scan Pyramids project started using this completely non-invasive technique. So what are muons? They are cosmic particles naturally raining down from space all around us. By placing special detectors both inside and outside the pyramid, physicists can track how these particles pass through the stone. It effectively allows them to X-ray 6 million tons of rock without moving a single pebble. And this specific technology triggered a rapid cascade of massive discoveries. They found an initial cavity in 2016. They hit the jackpot in 2017. And by 2023, they actually had cameras inside a sealed corridor. Over just a few years, this tech completely upended our understanding of the pyramid's internal structure.
The absolutely stunning revelation from all this was the Big Void. Confirmed in 2017, this is a 30-meter-long space located directly above the Grand Gallery. Just think about that for a second. A space the size of a commercial airplane, hidden inside the most heavily studied building on Earth. And we know for a fact it's real because it was confirmed independently by 3 separate particle physics teams from Japan and France, all using completely different muon detectors.
Now, whenever hard science disrupts established history, you're going to get friction. Initially, some traditional Egyptologists flat out dismissed the physics data, calling it a zero contribution. But the data was undeniable. Once endoscopes confirmed the North Face corridor in 2023, it was finally celebrated as a major discovery. It's a perfect example of the ongoing tension on the plateau today, where cutting-edge tech constantly bumps up against traditional methodologies.
And this incredible marriage of ancient stones and modern science isn't just limited to the Great Pyramid either.
Let's fast forward a bit to April 2026. Researchers focused on the smaller Menkaure Pyramid, which had recently been the center of this huge, intense debate over a granite cladding conservation project, a project developers championed but many archaeologists called an outright disaster. Right in the middle of this controversy, an advanced team targeted the pyramid's eastern face using ground-penetrating radar, ultrasound, and electrical resistivity tomography.
Well, the scanning data cut right through all that noise. It revealed exactly what they were hoping to find: 2 incredibly precise air-filled anomalies, hiding just behind a polished section of that granite wall. The sheer precision of these voids strongly suggests the presence of a completely undiscovered secret entrance. So, if particle physics and radar can unlock 4,500-year-old airplane-sized voids and secret entrances today, it leaves us with one absolutely thrilling question. What else is hiding in the stones? Right now, the Giza Plateau sits at a fragile crossroads. It faces severe urban encroachment from Cairo's rapid expansion, and rising groundwater is genuinely threatening the foundations of these monuments. Yet, as the massive Grand Egyptian Museum opens to flex the nation's cultural soft power and boost economic recovery, the drive to uncover Giza's secrets has literally never been stronger. The mysteries of the plateau are far from solved. The real question is, what will the very next scan reveal? Thank you so much for joining me for this explainer of the latest data. Keep questioning, keep learning, and I'll see you next time.